All right, let's just dive in. Overall, the project is an artificial evolution simulator where you design virtual creatures and train them to perform basic behaviors like swimming, walking, jumping, etc. In a three-dimensional environment. Right now, the project is kind of split into two modules. One is where the creatures are designed and built, and the other is where they're actually trained. First, I'm going to show the creature builder portion of that, where you design the body dimensions of the creature that you want. Alright, so this is the creature editor tool. I'll just load it up. Every creature is composed of a number of segments and each or blocks, each of which are connected by joints. So you can think of it like a skeleton, where every segment is a bone and every joint is a joint, just like an elbow or a knee, or anything like that. So every creature has a parent node or parent segment called the root node that everything else attaches to. This is basically the starting point. So I can right click where I might want a new segment created uh, and add one. When you add a new segment, it will start out with the same dimensions as the parent, so that it's roughly the same size as what you're going for. I can then manipulate the proportions of any of the segments, either with these little gizmo tools or the segment settings panel, which basically just gives slider control and numerical readouts for the values of things if you want to be slightly more precise. So these are actually the same as the tools. I can change the dimensions over here, or I can change them over here. It's the same thing. Similar with attach position. I can change where it's attached to the parent that way, or I can slide it around if that's what I like more. Um, the other attribute is I can give it an initial orientation if I want. So in any of the dimensions, right now it's capped at about 45 degrees, so it doesn't cause too many problems bending right back into its parent segment. Um, let's see, so I'll just go down the line. You can change the joint type. Basically just says what degree of freedom it has or how it bends. Um, if you want to see what it's going to look like, you can use the preview physics button, and this will just apply a turbulent random force so you can kind of see the range of motion of it. That was hinge X, so if I try hinge Y, see now it rotates that way. Or I can give it freedom in two axes, and now it can go up, down, left, or right. And that's true of all joints. And these are automatically connected when you add a segment, so the joint is just part of it. You can also make it fixed so it won't bend at all. Alright, so we can just start adding stuff then if we want. I'll just do a pretty simple setup here just to demonstrate some of the other stuff, and we'll just go down the line. So a common thing in nature is symmetry. So think of your arms or legs. Rather than me, if I wanted a copy of this on the other side, rather than making it and trying to get it just right, exactly the same as the other one, and then if I change this, I have to change that. There's an option for mirroring a segment across its parent. So if I go to this drop down, I now have a mirror image of this limb here, and if I make any changes to this, its corresponding mirror image is also affected. Similar to that, just to save time and make some more interesting looking body plans without too much manual effort. you can also recurse, which basically means add a copy of itself onto itself. Um, so basically, it takes this segment, adds a copy of that to itself, and you can do that not as many times as you want. I capped it just in case, but it makes it much more easy to have something like a backbone or a tentacle or a worm or whatever. You can also, there's a scale factor that will progressively shrink it as it adds more copies or grow. So you can have something kind of end up like a point more. And then we can also see what that looks like. All right, so the other options aren't too fancy. Joint angle limits will just allow it, it's basically what's the max angle that this joint can support. So we can just look at it with preview physics, see how it's much more flexible there. Whereas if I shrunk it down, um, now it hits its limit much quicker. So it's basically range of motion um, controls here. Um, let's see. These options won't be used too much, but forward bias basically just means that when you're using recursion, that it treats each successive segment as if it's coming out forward. So if I roll that, it will kind of, because this was attached to the bottom of its parent segment, each child segment, if forward bias is off, tries to be in the same location that its original connection was in. So you can see how that can cause problems with it intersecting itself. So generally, it defaults to 1. Similarly, the attach only to last is just to prevent, um, well, I'll just show you. So if I add a segment here, see how it's only attached to the very last segment in the chain. But if I uncheck this, it will be attached to every instance of that segment. So you could think of it as something like an insect or a centipede. You can have legs coming off each segment, and then I can add or remove segments easily as I want. I can move it anywhere, uh, change the scale or um, initial orientation, etc., to create something kind of weird without too much manual effort. Um, Alright, so that was basically it for how to build out a creature and set up the basic body plan. I'm going to just build a simple one right now just to demonstrate the other part of the system. Because as it is, the creature doesn't have any way to sense its environment or actually move its muscles. It just has the joints there. You can think of it kind of like a rag doll. So I'm just going to create like a simple worm creature. Just so we have something simple to work with. Give it a little tail, whatever. Um, make it a little longer. We can see how this will move like so. I can give it a little bit more flexibility. Yeah, that's good. Alright, so in order to let the creature actually interact with the environment, that's where the node add-ons system comes in play. So there are a bunch of different things I can add to each segment. Most notably, a joint angle sensor, which basically tells the creature the current angle of bend of each joint. So um, if it's in this rest position here, it will know that the joint isn't bent at all. Whereas if it's down like this, it will know that it's bent all the way to the extreme. Um, and I'm going to add that to uh, each of these segments. It's automatically added to each of them because they're a copy of itself, and the tail fin. The other really common one, I'm not going to go over all of these, um, is the joint motor. So this is what actually allows the creature to bend its limbs. You can give it an amount of force and speed to tell it how strong it is. I'm going to add that again to both of them. And then the other common uh, add-ons are actual value input. So basically, this just inputs kind of an external constant, um, or you can give it an oscillation, which is just over time. The signal will go positive, then back to zero, then negative, then back to zero, then positive. It's basically an internal clock for the creature, and it can use that as uh, a source for its movement, so it can time its muscle movement with the rate of this clock. So with that, uh, actually, I'll just go over just a couple other. You can change physical attributes like the friction or bounciness, the physical properties of each segment. And then there are a bunch of others that just allow the creature to get a better sense of its world. Um, it can tell what altitude it's at. It can sense what direction gravity is, kind of an accelerometer, like in your iPhone. It can also add thruster, so it could artificially push itself in certain ways if you want that, or make noise, uh, or have a weapon, or sense when it's touching something, for example. But I won't go into those. Alright, so now we have our creature. I think it's time to actually go see what it's like to train it. I'm gonna just save this out um, as example creature. Save that, and I'll open up the actual trainer module.